Okay, so let's scoot on. In this section, we're talking about solving exponential and logarithmic equations. And notice the directions. They say give an exact answer. What does that mean? No calculator. Remember that. Stay off the calculator. They don't want a decimal answer. They want an exact answer, even if you still have the word log written in it. To them, it's an exact answer because you're not rounding. So understand that's what it means to give an exact answer. Okay, so let's look at problem number 1. I'm trying to solve for x, agreed? But that's in the power position, isn't it? Which means this is an exponential function, right? Okay, so I need to knock this 4 out from under it so the x can fall to the ground, so to speak. Okay, so what's the inverse of an exponential function? Hopefully you said it. It's a log function, because exponential functions and log functions are inverses of each other, which means they will cancel each other out. Just like addition cancels subtraction, just like multiplication cancels division, right? Okay, but remember, exponential functions and log functions are inverses of each other only if the bases are the same. Only if the bases are the same. Remember that. Got it? Okay, so if I want to get rid of this exponential base 4, then I need to take the log base 4 of each side, because a log base 4 of an exponential base 4 will cancel each other out. But if I do it to one side, that's right, you've got to do it to the other side, which means on the left side remains an x. On the right side, I have log base 4 of 7. Are you with me? Cool. Now, x is by itself, isn't it? This is considered the exact answer. We're done. I'm going to be honest. Some authors of the book say the exact answer is actually when you change the base on it. Why? Because now they're base 10s, and so that's better. So just be careful of your homework assignment, what your author, the author of your book, considers an exact answer. Some will leave this one, some say it's that one. So again, watch the authors of the book. Got it? Okay, let's look at number 2. So, again, it's an exponential function because my x is in the power position. So I need to cancel this exponential function. That's right. What cancels an exponential function? A log function, which means I have to take the log base, that's right, e, because log base e and exponential base e cancel each other out, don't they? But you know as well as I do, you do it to one side, that's right, you do it to the other side, which means we're going to have 8x equaling log base e of 16, aren't we? Remember what log base e, there's another way of writing it. Yep, some of you said it. That is ln, log natural of 16. Cool? Okay, last but not least, that's right, divide by 8 so you can get the x by itself, which means we have the natural log of 16 divided by 8. Now, question for you. Can you cancel the 8 and the 16? Hopefully you said no. And some of you may be going, well, why? Because this ln and this 16 are stuck together. I can't have the word ln stand by itself. It's like writing a plus sign, and the plus sign is going, what do you want me to add? The ln is going, well, what do you want me to do? So as soon as you write a number with it, it's stuck together and you can't look at it separately. Same thing here. As soon as you write a number before and after the addition sign, they're stuck together. Got it? So no canceling the 8 and the 16. Cool? Okay. Let's look at number 3. By now I think you have a feeling what we're going to do. Good. You got to take the log base 5 to cancel the exponential base 5, right? So these guys are going to drop out. And when you do it to one side, that's right, you do it to the other. Which means what remains on the left is x minus 2, and on the right you have log base 5 of 7, don't you? Excellent. You got to get that 2 over. Correct. Add the 2 over, which means x equals log base 5 of 7 plus 2. Now, another question. Can you add the 7 and the 2 together? Hopefully you said no. And again, some of you may be going, why? Because this log is keeping that 7 attached to it. You can't have log without a base and without a number following. These guys are all one unit. It's considered one term. So some of you may want to put parentheses around this, or some of you, to make certain you keep it straight, may actually want to write the 2 first and then add the log base 5 of 7. Both of these answers are the same, so be very cautious how you look at them. Good? Okay, hang in there. Got some more examples for you. Okay, so let's take a look at number 4. I'm trying to solve for x, agreed? Which means I need to get rid of log, don't I? So remember, the inverse of a log function, that's right, is an exponential function as long as the bases are the same. Well, question, what's the base for number 4? Yeah, remember when you don't see it, that's a base 10, isn't it? Which means for us to cancel log base 10, I need an exponential base 10. So I need to take the exponential base 10 of both sides, because that'll cancel this log base 10. Are you with me? So notice what remains. On the left remains x, on the right is just 10 to the 2.5. And since they don't want a decimal, that's what they're going to get from me. Cool? X is by itself. We're good. Does that make sense? Okay. Look at number 5. I'm trying to get rid of this ln, aren't I? Now, I'm going to give a tip for some of you. For some of you, it may actually be a really good idea to write what ln means. That means log base e of x equaling negative 1.3. Why do I suggest that? Because now it's obvious what the base is. So we have to take exponential base e of both sides, don't we? Because exponential base e will cancel log base e, won't it? And remember, I said both sides. Which means in this particular case, x would be equal to e to the negative 1.3. Cool? How are we doing so far? Okay. Now, quick detour. Do you remember what the domain of a logarithmic function is? Yeah, the domain of a logarithmic function is 0 to infinity excluding the 0. Which means when we get our answer, we need to make certain that when we plug it in for x, we end up taking the log of a positive number. With me? We have to check these. In this case, I don't have a choice. I need to check them. I need to make certain that when I take this 10 to the 2.5 power and I plug it in for x, that I'm taking the log of a positive number. That's what I need to make certain of. And in this case, I am, because 10 to the 2.5 is a positive answer, which means I am taking the log of a positive number. So this answer is good to go. I don't have to worry about it being negative. Now this one. Some of you are going, oh, that answer is negative. Is it? Remember what a negative power does? Yeah, technically the negative power moves this thing to the denominator. So is that really a negative answer? No, it's a positive answer. It's a fraction, but it's a positive answer. And so when I take this positive answer and I plug it in for x, am I taking the log of a positive answer? And yes, I am. So this answer is also good to go. Check. This is the one thing you must do on a log function, on a log equation. When you solve it, you need to make certain that your answers, when you plug them back in, are allowing you to take the log of a positive number because the domain is greater than or equal to 0. Pardon me, not equal to 0. Your domain is greater than 0. Remember that parenthesis means greater than 0, not equal to 0. Good? Okay, look at number 6. Again, you see that ln? What base is it? Yeah, that's a base e, which means, and some of you may want to rewrite it, and some of you are like, I don't need to. You know who you are. I'm going to take the exponential base e of both sides, because exponential base e and log base e cancel, don't they? Good, which means we end up with 2x minus 5 equaling e to the 1.8. And now it's all algebra. I'm solving for x. I may not like the way the answer is looking, but since they want an exact answer, I must stay off the calculator. So, that's right, to solve for x, you're going to have to add the 5 to both sides. And to finally finish it off, you're going to have to divide both sides by 2, aren't you? And so be it. This is a funky looking answer, but nonetheless, this is the answer. Now I have to check it. I have to make certain that this number, when I plug it in here, will be positive. So let's think about this. E to the 1.8, will it be a positive answer? Yes. Plus 5, will it be a positive answer? Yes. Divided by 2, is it still positive? Yes. And I need to make certain when I plug this in that I'm going to get a number here, subtracting 5 is still going to be positive. And you can check it. You can plug this into the calculator and do 2 times this number. But I already know it's going to be a number that when I plug it in will remain, give this parenthesis to be greater than 0. I already know it. So this answer would also be good to go. Check. Cool? Okay, hang in there. Okay, so let's take a look at number 7. 7 is what kind of equation? Right, it's an exponential equation, isn't it? Because I don't see the word log whatsoever, and I'm noticing the x is in the power position. Agreed? Okay, so here's the thing. I need to get rid of the exponential base 2. That's right, you got to take the log base 2 of both sides, don't you? All right, so next line. Good, these guys cancel, which leaves you 2x equaling log base 2 of 28.6. That's right. Last thing you're going to have to do is divide by that 2, which means you get log base 2 of 28.6 divided by 2, don't you? Good? Quick question. Can you cancel the 2 and the 28.6? Excellent. You cannot. Good job. Okay, let's look at number 8. Yeah, I've got a log function, don't I? Or log equation, I should say. But in this case, I have the word log written 2 times, don't I? Yeah, that's going to be a little bit of a challenge. Because remember, addition acts like super glue? And super glue keeps these two things together, which means I can't look at them separately. Which means I can't take exponential base 3 of this and then take exponential base 3 of this. Because the addition side says they're together. You can't split them up. Which means I don't want the word log written twice. I want it written once. So how do I recombine these so it's written one time? Good, some of you said it. The properties, right? We had the properties of logs, didn't we? But we can only recombine them when the bases are the same. Are these bases the same? Excellent, they are. Which means I can rewrite this as log base 3 of 5, good, times x equals 0. Times x. Addition goes to multiplication when you're going backwards, when you're recombining it. Okay, now, log base 3 needs to go. The inverse of a log base 3, that's right, is an exponential base 3. So I need to take an exponential base 3 of both sides, don't I? That'll cancel this out. Agreed? Which will leave me with 5x equaling 3 to the power of 0. And now it's all algebra. What's 3 to the power of 0? Good, 1. So I have 5x equaling 1 and x equaling 1/5. Are we done? Not quite. You've got to make sure this answer, when you plug it in, ends up taking the log of a positive number. And am I taking the log of a positive number when I plug in a positive 1/5? I certainly am. So this answer is good to go. Cool? Okay, let's look at number 9. Once again, I have 2 logs and I want 1 log. So I need to recombine them. But what do you have to make for certain of first before you recombine? Good, the bases are the same. Are the bases the same? Excellent. Which means I get to recombine them. And I get to write log base 7. Now, subtraction recombines to what? Good, I heard you. Division. So that's 8 over x, isn't it? Equaling to 2. And now we get to get rid of a log base 7 by using exponential base 7. So I need an exponential base of 7 on both sides, which cancels this guy, doesn't it? Which will leave me 8 over x equaling 7 squared, right? Okay, pure algebra at this point. So 8 over x equaling 49. Get rid of the x, right? Get rid of that denominator. So 8 equals 49x. And x equals this lovely fraction of 8 over 49. Are we done? Almost. You've got to check this answer and make sure that when you plug it back in for x, you're taking the log of a positive number. Are you? Yes, you are. So yes, this answer is good to go. Check. Okay, hang in there. Got it. Okay, so let's take a look at number 10. Notice I have 2 logs again, and addition is between them, correct? Okay, can't have 2 logs, only 1. So I need to recombine these to 1 log. But before you do, you have to make sure the bases are the same. So what are my bases? Yeah, even though I don't see them, they're both a base 10, aren't they? Excellent. Which means this is going to look like log, and some of you may want to write that base 10, of x times x minus 9 in parentheses equaling 1. Right? Good. And some of you may want to distribute first. You could do one of 2 things. Distribution is one step you could do next. So let's just do that because some of you are like, I want to distribute. So great. Let's distribute. So I have x squared minus 9x, correct? Equaling 1. Okay, so now that I have 1 log written, I'm trying to get to the x, and in my way of getting to the x is a log base 10, isn't it? So how do I get rid of a log base 10? Good, an exponential base 10, which means I'm going to take an exponential base 10 to both sides, which means those guys get to cancel, don't they? And what remains is x squared minus 9x equaling 10 to the power of 1. And from here, all algebra. What's 10 to the power of 1? Good, 10. Okay, question. I have got a 2nd degree equation. I've got an equation with a power of 2 here. I've got a square there. How do you solve those equations with the power of 2? You got a factor, which means you need to make certain this equation is set equal to, I heard ya, 0. So we got to minus that 10 off of both sides, don't we? Okay, and now we get to factor. So you do your factoring, I'll do my factoring, and hopefully we get the same. Did we? Wonderful. And then remember, each parenthesis gets set equal to 0. This part is nothing new. Nothing new whatsoever. So I end up with 2 answers. I end up with x equaling a positive 10 and x equaling a negative 1. Good? Are we done? Yeah, I heard ya. Not quite. I have to make sure that both of these answers work. So I'm going to take one answer at a time. I'm going to take the 10. I'm going to get rid of these x's, and in place of these x's, I'm going to put in this 10, because I want to know if this answer works. And you're like, what do you mean by work again? I need to make sure that when I take the log of these, that I'm going to get a positive, or that I'm taking the log of a positive number. With me? By the way, I'm just going to get rid of this writing of the base because the original problem did not have it. So I'm getting rid of that also. Okay, so here's the question. Are we taking the log of a positive number? Yes. Are we taking the log of a positive number? Yes. Remember, it has to be greater than 0. And so this answer works. Check. I got one more answer to try. So let me get rid of this 10. And word of caution, do not exclude the number just because it's negative. Some of these negative answers actually work depending on how the original problem is written. So, but let me plug in the -1 to this problem. And are you taking the log of a number greater than 0? This one, I don't even care to check this one. This first one failed, which means this answer isn't working whatsoever. 2 answers, only 1 checked. Therefore, this problem only has 1 answer. And in this case, it's x equaling 10. Cool? Hang in there. 2 more problems. Okay, so let's look at these last 2 problems. Let's look at number 11. Do you see I have 2 logs written once again with a subtraction sign in between? Do I want 2 logs written or do I want it written one time? Right, I want it written as a single log. Are these bases the same? Gratefully they are, which means I can recombine them. And subtraction will recombine to, good, division, which means this problem is looking like log base 3 of x plus 4 divided by x equaling 4. Agreed? Okay, now remember, I need to get to that x, so this log base 3 needs to go away. Correct. You're going to have to take the base 3 exponential of both sides, aren't you? Which is going to cancel this log base 3. Correct? Okay. Which on the left side means I have this x plus 4 divided by x equaling 3 to the power of 4. And at this point, it's all algebra. What's 3 to the power of 4? 81. Which means I have this fraction equaling 81. Do I want the denominator of x? Nope, so you're going to have to, excellent, multiply both sides by it, which means x plus 4 equals 81x. And then, good, get the x's on the same side, which means I have 4 equaling 80x. And last but not least, divide by the 80. So I have 4 divided by 80 equaling x, which reduces to 1 over 20 equaling x. Wonderful. Are we done? Not quite. We have to check this answer and make certain that when we plug it back in for these x's, that I'm taking the log of a positive number, remember? Okay, so I have a positive 1 over 20 plus 4. Good. That's going to be a positive number, so we're good. I have the log of a positive 120. Excellent. That's also good. So this problem, check. This answer, good to go. Check. With me? Okay. So let's take a look at number 12. On number 12, I have 2 logs written once again with an addition sign in between. That's right. I want it written one time. So we recombine addition to, excellent, multiplication. So we have log base 3 of x times the quantity of x plus 2 equaling 1, right? And you're like, hey, that's looking like number 9. Right, it's looking like number 9, which means you're going to distribute that x. So I have 5x squared plus 2x, right, after you distribute. And yeah, just like number 11, just like numbers 10 and 9, I don't want this log base 3 here. So I am going to take the exponential base 3 of both sides to cancel this. Agreed? Okay, so we have 5x squared plus 2x equals 3 to the power of 1. And again, at this point, it's all algebra. So follow along. 3 to the power of 1 is just 3. I have this x squared once again, which means you're going to have to factor. Excellent. So we have 5x squared plus 2x minus 3 equals 0. And when I factor it, I get the parentheses of 5x minus 3 times the parentheses of x plus 1. Good? Which means after I set both parentheses equal to 0, I end up with x equaling a positive 3 over 5 and x equaling a negative 1. Okay, so here's the deal. We have to check these answers and make sure they work, right? Now, word of caution. Just because this answer is negative doesn't mean it does not work. Because depending on how the original problems are written, it could actually work. However, in this case, when I plug in a negative 1 for this x, I'm taking the log of a negative number, aren't I? So yes, clearly this one does not work. If I plug a positive 3/5, yes, this works. A positive 3/5, yes, this also works because I'm taking the log of positive numbers. So this answer works. 2 answers we arrived at, only 1 answer is working for us. Cool? Okay, so you have fun solving exponential logarithmic equations. I'll catch you on the flip side.